Welcome back to the Deep Dive. Today, we are staring into what might be the greatest, most enduring crisis in modern cosmology.
It's a big one.
A crisis of invisibility that really, it defines the ultimate reality of our universe. And you, the listener, you know the numbers well.
Oh yeah, they're everywhere.
Roughly 95% of the cosmos, so the overwhelming majority of everything that exists, is made up of two things we can't see, can't touch, or measure directly.
But we know they're there. We see their effects.
Exactly. They're profound gravitational effects. We're talking, of course, about dark matter and dark energy.
It really is the ultimate cosmic paradox of modern science. We've built this towering, intricate, and incredibly successful framework.
The Standard Model of Cosmology, or CDM.
Right, lambda CDM. And it fits the observed data perfectly. I mean, from the way galaxies are scattered across the universe to the echo of the Big Bang.
The cosmic microwave background.
Exactly. But it's fundamentally built on these massive unknown placeholders. To make the mathematics balance, we're forced to invent vast quantities of unknown stuff.
Invisible particles.
Exotic fields, mysterious pressures. It's a whole zoo of unknowns.
And it's the sheer complexity of these balancing acts that creates this idiot philosophical problem, right? Cosmologists today use, upwards of 20 free parameters just to describe the universe inside that model.
At least.
And when we say free parameters, we mean numbers that aren't derived from some core underlying physical principle. They're just measured.
They're essentially tuning knobs. We observe a galaxy spinning too fast, and then we dial the dark matter halo parameters until our model's curve fits the data.
So you're inserting the observation by hand.
You are. You measure the universe's expansion rate, and you just plug that number in for the dark energy density. These aren't derived constants like, say, the speed of light.
They're not fundamental.
No. And if physics is truly about revealing the profound simplicity of nature, a 20-plus parameter model suggests, well, it feels like we've missed the core concept entirely.
Which is why our mission today is to dive into a theory that just rejects this complexity completely. It's called the Unified Chronofractal Field, or UCF.
And specifically version 6.0, which the authors called the zero-parameter limit.
And the claim is, it's extraordinarily radical.
It is. UCF doesn't propose to just tweak the standard model, maybe find a better particle for dark matter. It replaces the entire dark sector.
Both dark matter and dark energy.
Both. By saying they aren't substances at all, they are merely, and this is the key, geometric inevitabilities. They're derived from two fundamental mathematical constants.
So the implication is stunning, that physics is actually simpler, more purely mathematical than we currently assume.
Much simpler.
This theory claims that all those observational anomalies, from galaxies spinning too fast to the universe expanding at an accelerating rate, they all come from just two constants.
That's right, E nu, which defines the fractal dimension of time, and pi, which defines the topological limit of space.
So we're talking about pure, unavoidable geometry, replacing the need for invisible particles and exotic fields.
No new particle accelerators needed, just a better understanding of how time and space fundamentally work.
Okay, let's unpack this using the central visual concept from the source material, because it frames the problem of dark matter so beautifully.
The ocean liner analogy, it's perfect.
So imagine you are observing a gigantic ocean liner. That's our metaphor for a big spiral galaxy, and it's moving slowly across a vast, still, dark ocean.
And based on the ship's known mass, its size, its speed, you can calculate the expected turbulence, the wake it should leave behind.
The calculation, that's our current physics. That's general relativity and Newtonian gravity.
Right.
But when you actually look at the ocean liner, the water behind it is just boiling with turbulence. It's churning far wider, far deeper, far more violently than the ship's hull alone should ever generate.
And that excessive, unaccounted-for turbulence, that's the galactic rotation anomaly. That's the missing gravitational pull we currently talk up to dark matter.
So how does the standard model solve this?
The lambda CDM solution is to assume your initial premise was wrong. It says there must be massive, ghostly, semi-transparent submarines running directly beneath the surface.
Synchronized perfectly with the liner.
Perfectly. And their invisible propellers are generating all that extra churning. We can't see the submarines, but their gravitational effect, the turbulence, must be there.
So we invented invisible submarines just to explain the visible churning water. That is the core analogy for dark matter particles, like WIMPs.
It is. And this is where UCF steps in and says, stop looking for invisible submarines. They don't exist.
So where does the turbulence come from?
It's the ship's own chronofractal wake. It's a geometrically perfect, self-similar memory effect that naturally extends far behind the mass, because it's inherent in the fluid in space-time itself.
So the complexity we see is just the geometric result of mass moving through a slightly fractal dimension of time.
That's the idea. So let's start by dissecting why the standard model painted itself into this corner.
And how UCF claims to achieve this radical simplicity.
Okay, so when we talk about lambda CDM, we have to give it credit. It is a stunning achievement of descriptive fitting.
Right, descriptive. It describes what we see incredibly well.
Incredibly. We can model the universe on computers with amazing accuracy. But the critique here, the one that's central to UCF, is that this descriptive success comes at the cost of explanatory parsimony.
It's not simple. It's not elegant.
Not at all. And that failure of parsimony, it really shows up in those 20-plus free parameters. You need to input the ratio of cold dark matter to critical density, the baryonic matter density.
The amplitude of primordial fluctuations, the reionization optical depth, it just goes on and on.
And none of these numbers come from a deeper principle like symmetry or geometry. They're measured, and then they're just plugged in.
And maybe the worst offender is the dark matter halo profile, right?
Oh, absolutely. Standard models require you to specify exactly how dark matter is distributed around a galaxy like the NFW profile, and then you have to adjust the parameters for every single galaxy to match its rotation curve.
It's fine-tuning on a galactic scale.
It is. It demands that the unseen ingredients conspire perfectly with the visible stars and gas. It's messy.
Which is why the core philosophy of UCF is so different. It says a truly fundamental theory has to have zero free parameters that aren't derived from first principles.
The claim is that physics is, at its heart, a branch of geometry, and everything we see has to be an analytical derivation of that geometry.
And UCF version 6.0 says it gets there with just two core constants, not as measured values, but as geometric axioms.
Let's start with the first one, inner, for sure. UCF calls it the engine of time.
And what's fascinating is where this number comes from. It's not arbitrary.
Not at all. It's the unique positive solution to a very specific, very simple quadratic equation. N squared plus minus 1 equals 0.
And when you solve that, you get the conjugate of the golden ratio, approximately 0.618034.
Exactly. And the reason for this specific number, the sources explain, is that it defines the scaling behavior of a system that's optimizing how it retains information in a self-similar way.
Like a natural organizing principle.
You can think of it like that. It's what's called a renormalization group fixed point. It's the simplest possible scaling relationship that allows for continuous nonlinear growth with memory.
So the golden ratio isn't just some beautiful coincidence showing up in nature. The theory says it's the only mathematically stable constant that lets time have a memory.
That's the axiom. And its role is to define the fractal dimension of time, which is d subscript t equals 1 plus 4.
Standard physics just assumes dt is exactly 1. Smooth linear time.
Right. UCF says time has this inherent fractal excess, a little bit of roughness, a little bit of self-reference. And that roughness is the engine of growth. It's the origin of the negative pressure we call dark energy.
Okay, that's a huge conceptual shift. So dark energy isn't some weird fluid that just appeared. It's the geometric result of time itself being slightly more than one-dimensional.
Precisely. Now let's get to the second axiom. This is the big breakthrough in version 6.0, the limit of space defined by.
Right, because critics of the earlier versions always pointed to this one empirical fudge factor they had, the mass damping coefficient.
They did. It described how quickly the gravitational wake of a galaxy spreads out and dilutes, and they had measured it empirically to be about 0.32.
Which was a good fit, but it wasn't derived. It was another one of those plugged-in numbers.
It was. But UCF v6.0 realized that this measured value was just the shadow of a deeper geometric truth. They elevated it to an identity, the topological damping identity.
Which states that t is exactly 1 over.
Yes. Since p is about 3.14159, 1 over p is about 0.3183, and this is the spherical damping term.
This is a powerful move because it gets rid of the last free parameter. But what's the justification? Why?
The justification is purely geometric. When a massive object moves and generates its field memory, its historicity, that influence spreads outward in an isotropic three-dimensional vacuum, spherically. So the dilution of that information density must be constrained by the topology of the sphere, specifically by the constant sub. The math just falls out from the geometry.
So the amount of gravitational influence a galaxy has is limited by the fact that we live in 3D space where things spread out in spheres.
That's it. And crucially, the tiny deviation between the old empirical fit, 0.32, and the new geometric truth, about 0.3183, is less than 0.6%.
Wow.
That tiny difference is what validates the whole shift. It confirms they were measuring one all along.
That gives you a lot of confidence. Okay, let's look at the master equation now, which brings these two forces together, the growth from M and the limit from Runt.
The equation for the chi field, the effect of gravity, is deceptively simple. Its chi is proportional to the mass m times the age to the power of e times the mass m to the power of -1 over pi.
Let's break that down one more time.
M is the baryonic mass, the visible stuff. To the e term is the chronofractal scaling. This means the gravitational influence of that mass actually grows over time.
That's the memory effect. The weight gets deeper over billions of years.
Exactly. That's historicity. Then you have the m to the -1 over term. That's the spherical damping. It shows how that growing influence is diluted by the spherical geometry of space.
So the conclusion is just breathtaking. The dynamics of gravity and the cosmos are dictated entirely by two pure mathematical constants, the golden ratio conjugate and Praken. No free parameters.
Zero. Now let's see how this radical simplicity actually handles the data.
So the first and most obvious test for UCF is to apply this master equation to the problem that started it all.
The anomalous rotation of spiral galaxies.
We're back to the ocean liner.
Yeah.
And we previously needed those invisible submarines, the dark matter halos, to give that extra gravitational tug far from the galactic center.
Right. And UCF just gets rid of the submarines entirely. The excess turbulence, that missing gravitational pull, is the chronofractal wake. The memory. When the baryonic mass m moves through space-time, it generates this profound historical wake, historicity in the metric itself. And that wake creates an effective gravitational potential well that extends far out, perfectly mimicking what we used to call a dark matter halo.
This is the critical shift. We were looking for missing mass, but the theory is saying we were misinterpreting the observation. It's not missing mass.
It's missing geometry.
We just failed to account for the geometric fact that time has memory.
Exactly.
Okay, but I have to stop you here. I have to put on my skeptic's hat for a second.
And please do.
Critics would say this sounds a bit like numerology or, just MEN-OND modified Newtonian dynamics with extra steps. If this effect is pure geometry, a memory wake, why does it only seem to show up around huge, rotating galaxies?
That's a great question.
Why don't we see these wakes around smaller things like globular clusters or even, a big rogue planet?
An essential question. And the answer from UCF lies in the scale dependence. Look at the chronofractal term again. To the power of O.
Age to the power of nu.
Right. The historicity effect is cumulative. It depends on both the mass and the cosmic age. So for smaller objects like star clusters or planets, the wake they generate is just. It's negligible compared to their immediate Newtonian gravity.
It's there, but it's too faint to matter.
Right. The effect only becomes significant, dominant even, when you have two things together. Massive, large-scale structures like galaxies combined with immense cosmic age, billions of years. Only then does the chronofractal memory become the main force out in the galactic suburbs.
Okay, so the wake is everywhere. But it's only cosmologically important when both the time factor and the mass factor are huge.
Exactly. And this geometric view lets UCF do something that lambda CDM just can't.
Which
can analytically derive the Tully-Fisher relation.
Right, Tully-Fisher. That's the bedrock of galactic observation. It's that empirical fact that a galaxy's brightness, its baryonic mass, is tightly correlated with the fourth power of its rotation speed.
A beautifully clean but completely unexplained correlation in the standard model.
In lambda CDM, trying to match Tully-Fisher is a nightmare, right? You have to meticulously tune the dark matter halo for every single galaxy to make sure the visible and invisible parts conspire to produce that specific v to the fourth relation.
It's fitting a very complex model to a very simple observation.
So how does the UCF master equation with just in and fud derive it straight from the math?
Okay, so we start with the flat rotation velocity, v flat. That velocity is determined by the total effective gravity, which is chi. So v flat squared is proportional to chi.
Right.
We can substitute in the master equation, but we'll focus on just the mass dependency. We can assume the time term, to the F, is roughly constant for all the older galaxies we measure.
So it just becomes a constant factor we can ignore for the proportionality.
Correct. So we're left with the phi-flat squared is proportional to the mass m times the damping term, which is m to the power of -1 over m.
Okay, so v squared is proportional to m times m to the -1 over.
And using the rules of exponents, that simplifies to v-flat squared is proportional to m to the power of 1 minus 1 over 30.
This is where the geometric constant plays its big role, since 1 over rho is about 0.318.
The exponent, 1 minus that, is about 0.682.
So the squared velocity is proportional to mass to the power of 0.682.
And if we take the square root to find the velocity itself, we just have the exponent. So v-flat is proportional to m to the power of 0.341.
And that's the analytical prediction for how speed scales with mass, derived purely from the geometry of a sphere.
That's it. And if you invert that relation to get the luminosity-velocity scaling, the one people call the v-fourth relation,
you get luminosity is proportional to v to the power of 1 over 0.341.
which gives you L is proportional to v to the 2.94, which aligns remarkably well with the observed scaling for spiral galaxies.
That's the power of parsimony. You take a simple geometric fact, 1 over ρ, and you analytically produce the core observation that needs a whole scaffold of dark matter tuning in the standard model.
And the theory goes further. It subjects itself to the ultimate zero-parameter test, calculating the rotation curve of Andromeda.
M31, our closest major neighbor, the perfect lab.
The test is simple. Can we calculate Andromeda's observed rotation speed using only its known baryonic mass, its age, and the constants omen?
No tuning, no halo profiles.
None. You just plug those numbers into the full chronofractal master equation.
And what does the math predict?
The UCF prediction for M31's flat rotation velocity is between 220 and 240 kilometers per second.
And the actual measurement?
The measured speed is 225 plus or minus 20 kilometers per second.
It lands it right in the middle of the bullseye.
Right in the middle. This confirms two things at once. First, the validity of the one axiom. And second, the implication that all those maps of dark matter around Andromeda were never maps of particles.
They were just maps of how spherical geometry dilutes the gravitational wake of the visible matter.
Exactly. It shifts the focus from particles to field dynamics.
Okay, quickly, what about gravitational lensing? That's the other big piece of evidence for dark matter.
Right, the bending of light. Observations show light bends around galaxy clusters much more than the visible matter should allow.
Dark matter is needed to provide the extra gravity. How does UCF do it?
It uses the enhanced Chi potential. The total effective gravity is boosted by that chronofractal term to the N. The mass has had billions of years to build up its historical wake.
So the total gravitational influence that bends light is much greater than just the baryonic mass alone.
Precisely. The light isn't bending around invisible submarines. It's bending around the vast geometric memory bubble that the visible mass created over cosmic time.
So the lensing problem is also solved by understanding time's fractal nature.
That's the claim.
So we've seen how dark matter can be reinterpreted as a geometric damping effect from Hill. Now we turn to the really big one.
The big one.
Dark energy. The stuff that makes up 70% of the cosmic pie and is driving the universe's accelerating expansion.
In lambda CDM, dark energy is the cosmological constant, lambda, which means it's a constant energy density everywhere in space and time.
Which corresponds to an equation of state parameter, W, of exactly -1.
Exactly -1. Again, it's the simplest mathematical placeholder, but it's a parameter inserted by hand with no fundamental derivation.
But UCF says dark energy isn't a constant vacuum energy. It's a geometric necessity that comes directly from the fractal nature of time, from Mia.
That's right. Going back to axiom 1, time has that tiny excess dimensionality of about 0.618. And that fractal structure inherently generates negative pressure. It drives acceleration.
The universe accelerates because, at the deepest level, time itself is fractal.
It's the engine of growth in continuous action.
Okay, so the driving force is Mia. The structure of time creates the push. But the universe is expanding spatially in 3 dimensions. How do we connect the temporal push to the spatial result?
This is where the third balance principle comes in. It's critical. The fractal excess of time exerts negative pressure, but that pressure has to be distributed isotropically.
Uniformly.
Uniformly across our observed 3 spatial dimensions. If it wasn't balanced, space would look anisotropic, which we know it doesn't.
So the negative pressure from the 1 fractal time dimension has to be shared equally by the 3 spatial dimensions. You have to divide by 3.
Exactly. And that simple geometric requirement leads directly to the zero-parameter derivation of the dark energy equation of state, ρ naught.
Which is normally the ratio of pressure to energy density.
Right. If ρ were perfectly -1, pressure would exactly cancel energy density. But with the fractal addition, the formula becomes ρ naught equals -1 plus E divided by 3.
That's it.
That's it. This simple identity yields a precise, non-negotiable zero-parameter prediction.
Which is what?
Ρ naught is approximately negative 0.793989. This value is inherent to the geometry. It's not observed, it's derived.
And this prediction is monumental because it's completely incompatible with the standard model.
Strictly incompatible.
If UCF is right, dark energy is definitively not a cosmological constant. It has to be evolving and slightly less negative than -1. It has to be around negative 0.794.
The geometric stakes could not be higher. All of cosmology hinges on distinguishing between W equals -1 and W equals -0.794.
And the theory doesn't stop there. It also gives a second, equally specific prediction about how dark energy evolves. It predicts a thawing model.
Correct. The evolution is described by the term WA, the rate of change of W. And this corresponds to the second order or kinetic component of the fractal scaling. This term is governed by E squared.
And the third balance principle applies here too, divide by 3.
Yes, which leads to the second zero-parameter formula, WA equals squared divided by 3.
And the precise prediction for that.
It comes out to approximately positive, -0.127322.
Okay, so since WA is positive, that means dark energy was deeper, more negative, closer to -1 in the past, and it's been slowly thawing toward today's value of -0.794.
That is the prediction. So, to sum it up, UCF provides two highly specific, non-negotiable geometric predictions for cosmic acceleration. W naught is about -0.794 and WA is about +0.127. The entire framework stands or falls on those two numbers.
So a theory that claims to be this unified has to hold up everywhere, not just on the grandest cosmological scales, but also locally, right here in the solar system.
And even at the quantum level.
Exactly. And UCF predicts a really fascinating residual signature, not in distant galaxies, but in the time signals beamed back from spacecraft orbiting Mars.
The solar system chronometry test? The Mars drift anomaly?
Standard general relativity assumes time flows smoothly. But if time is fractal, if DOT is 1 plus E, then time flows just a tiny bit differently. It should lead to a tiny metric drift.
And the theory makes a really crucial distinction here. It's about the trajectory channel versus the clock channel.
What do you mean by that?
A lot of alternative gravity theories look for a trajectory channel error, a slight deviation in a planet's physical path.
Right, it's orbit decaying or something.
Exactly. UCF clarifies that the main effect of fractal time isn't a spatial path deviation. It's a deviation in the fundamental frequency standard you're using to measure that path. The effect is hidden in the timing of the signal, not the distance.
Okay, so where would we look for this subtle clock anomaly?
In the Deep Space Network, the DSN, they use these incredibly precise two-way Doppler links to talk to probes like the Mars Reconnaissance Orbiter.
A signal goes from Earth to Mars, and the return signal measures the frequency shift to calculate velocity and distance.
Right. And the UCF prediction is that there should be a cumulative timestamp drift of 61.92 microseconds per year in that Earth-Mars link.
62 microseconds a year. Over a decade, that's over half a millisecond. That sounds like it should be easily detectable in all the DSN data we have.
It should be, but, and this is the critical operational warning from the UCF researchers, DSN filters currently interpret this signal as clock noise and routinely remove it.
Wait, so hold on. We're talking about a Kalman filter, right? The standard technique to separate signal from noise. How does it make that mistake?
A Kalman filter is designed based on assumptions about the underlying physics. And the baseline assumption in DSN navigation is that general relativity is correct and time flows linearly.
Okay.
So if the filter sees a small linear drift in the frequency residual, a predictable deviation over a long time, its operational assumption is that it must be an instrumental flaw. The clock on Earth or the probe must be aging slightly.
So because the linear drift doesn't fit the assumed model of gravity, the filter automatically calls it noise and digitally zeroes it out to clean the data.
Precisely. They're filtering out a fundamental geometric signature of space-time simply because it doesn't fit the existing standard model assumptions.
Yeah.
The UCF theory states emphatically, do not zero this drift. It is the chronofractal horizon of the solar system.
That is just extraordinary. It means the proof of this theory might already be sitting in archived government data, labeled as noise, just waiting for someone to go in, disable the clock bias removal algorithms, and find it.
Let's move from the solar system to the quantum realm, the Casimir effect.
The pressure from virtual particles in the vacuum between two plates. Standard QED predicts this pressure scales as distance to the negative fourth power.
Right. P is proportional to d to the minus 4. That exponent, 4, corresponds to the 4 dimensions of spacetime.
But if time is fractal, the effective dimensionality has to be greater than 4.
Correct. UCF predicts the effective dimensionality of the vacuum and effective is enhanced by the fractal depth of time. The formula they propose is n effective equals 4 plus 2.
Why 2?
The sources say that vacuum fluctuations interact with both the forward and backward chronofractal horizons. It's a symmetrical interaction, so it requires 2.
So n effective is about 4 plus 2 times 0.618, giving us an effective dimensionality of about 5.236.
Which means the Casimir force should show a steeper fall-off than the classical d to the minus 4 prediction. It would be a direct confirmation of fractal time at the quantum boundary.
And this has huge implications for the cosmological constant problem, the infamous 10 to the 120 discrepancy.
Absolutely. The problem is that QED predicts a vacuum energy density 10 to the 120 times larger than what we observe as dark energy. It's the biggest error in science.
How does UCF fix it?
By changing the geometry of the vacuum, the energy is naturally renormalized and contained within the chronofractal field. It doesn't integrate up to that catastrophic Planck scale.
Right.
Instead, it just manifests macroscopically as the geometric pressure we see, where W is about minus 0.794.
It connects the quantum foam directly to cosmic acceleration with just the one constant, a truly unified framework.
Which brings us to the final hurdle, the falsification matrix, the Krupp-Stahl check.
The non-negotiable tests.
The first is the Euclid Space Telescope mission. It's going to measure the dark energy parameters, W0 and WA, with incredible precision.
The prediction matrix is completely unforgiving. Lambda CDM demands dou-E0 is -1 and WA is 0.
And UCF demands dou-0 is minus 0.794 and WA is plus 0.127.
The Euclid trap is set. If Euclid measures dou-0 is -1 plus or minus 0.02, UCF is immediately dead.
Falsified. But if Euclid confirms W lands near minus 0.8, then the standard model is falsified and the geometric origin of dark energy is confirmed.
And the second major test is purely computational.
The Mars signal extraction, the ultimate local test. Navigation teams have to reanalyze the DSN archives without the standard clock bias removal. If they pull out that predicted 61.9 microsecond per year linear drift from the raw data, it proves the chronofractal field is real.
So we've already confirmed the damping from 1/over with Andromeda. The entire future of this cosmology now rests on a clock and a telescope.
That's right.
This has been a true deep dive into a theory that is, well, audacious in its simplicity, but incredibly powerful in its analytic reach.
It really is.
The unified chronofractal field says that this vast, complex, invisible dark sector that makes up 95% of the universe isn't some massive inventory of new particles or exotic energy we invented to save the model.
It's just a geometric inevitability.
It replaces dark matter, the invisible submarines, with the memory of mass moving through time, its historicity. And that wake is damped by spherical space, defined by 1/over.
And it replaces dark energy, the constant fluid, with the fundamental fractal dimension of time.
Two mathematical constants, Enan, defining the entire cosmic show.
The elegance of it is in that idea that physics is simple, humans made it hard. We spent decades, billions of dollars, hunting for WIMPs and inventing complex theories, when the answer, according to UCF, was hidden in the geometry of our own dimensions.
We needed to stop searching for mysterious stuff and start looking for the mathematically perfect wake in space-time itself.
And the key takeaway for me is the power of that zero-parameter constraint. The ability to derive the rotation speed of Andromeda and the exact rate of cosmic acceleration using nothing but baryonic mass, age, and two universal mathematical constants.
That's the highest form of scientific parsimony. It forces you to reconsider the fundamental ingredients of reality.
It does.
Which brings us back full circle to the most provocative thought this entire theory leaves us with. And it's encapsulated perfectly by that Mars drift anomaly. We know, according to UCF calculation, that the chronofractal drift, that signature of time's fractal nature, 61.9 microseconds per year, is in the archived Deep Space Network data right now.
It's sitting there.
Currently being interpreted by DSN Coleman filters as instrumental noise and digitally thrown away.
So the question for you, the listener, is this. If a fundamental truth about the geometry of our spacetime is currently being filtered out of our scientific data because it doesn't align with the century-old assumptions of our existing standard model, what other profound signals about the structure of reality are we missing? What else is sitting in the noise floor waiting for us to stop removing the bias?